Hello, everyone. This is Michael Franti at Portworx. Thanks for joining our webinar today on data security and DR strategies for Kubernetes. We're going to give folks another minute to join, and then we'll go ahead and get started. Thank you. Okay, everyone, let's go ahead and get started. Thanks for joining Data Security and DR Strategies for Kubernetes webinar today. My name is Michael Franti. I'm VP of Product and Market Strategy at Portworx, and I'm joined by my colleague Prashant Ratti, who's Director of Product Management. Last week was a very exciting week for Portworx. We announced the release of Portworx Enterprise 2.1, which adds critical features around data security and disaster recovery for stateful services running on Kubernetes. And the bulk of our webinar today will be focused on addressing that topic. And so what I'm going to do is I'm just going to give a brief overview of Portworx, so that we can kind of set the scene. And then I will hand it over to Prashant, who will go into a deep dive of these new capabilities. And as always, with these webinars, please do ask as many questions as you would like. We try to answer all of them. You'll see a little questions widget as part of the GoToMeeting interface. So please just ask those questions, and we'll address them as we go along, and also at the end. Thanks. Okay, so just to level set, what we see across the industry is that enterprises are building application platforms with Kubernetes, and they're doing that to increase the agility of their organization, to unleash innovation from individual developers, to empower them to build and run applications more quickly, to get to market faster, in many cases to optimize their infrastructure, which could mean either just pure efficiency, or it could even mean cost savings in terms of the densities that containerization allows. And what we've seen is that organizations who go on that Kubernetes journey have a lot of success initially getting new apps onto the platform. But there comes a time in which it's increasingly difficult for new apps to be deployed on Kubernetes. And the cause for that hurdle, or that, if you will, tends to be hard business requirements that cannot be shed, right? That we can't, change the application to not have these business requirements. And at the same time, Kubernetes alone does not support the capabilities that would allow us to solve those business requirements. And so we're adopting Kubernetes in our organization. We're getting a lot of benefits. We want to do more of it, but we run into these barriers. And those barriers tend to have to do with data. So I might have an application with sensitive user data that needs to be secured in a particular way. I might have apps with very strict SLAs around performance or compliance or disaster recovery. And as I try to deploy those applications onto Kubernetes, as I work with my business unit partners to do that, they ask questions that me as a platform architect are unable to answer. well, what is the DR strategy for your Kubernetes cluster? Well, actually, we don't have a DR strategy. What is the role-based access control for data? I need to make sure that other Kubernetes users can't access my data. Well, we don't provide role-based access controls for data. Those are conversations that we see playing out over and over again. And kind of if you're in that situation, you are not alone. So a recent survey by the New Stack found that 80% of enterprises list data management, persistent storage, and disaster recovery as top barriers limiting container adoption. And Gartner echoes by saying in a recent report that lack of container native data services are really a big problem when it comes to deploying state applications on Kubernetes. Portworx is 100% focused on solving this problem for enterprises. We provide kind of enterprise class security and data management that you would expect from a traditional enterprise class technology vendor, but we do it in a way that's fully manageable and fully automatable and integrated with Kubernetes workflows. So you can adopt Kubernetes as your single application management platform, and yet not sacrifice the ability to handle those mission critical business requirements like security, like disaster recovery, like data management. We bring a unique mix of cloud expertise to bear on this problem. So first of all, kind of the DNA of our company is very deeply rooted in storage and data services. We have folks who have come from the leading storage and data management technology providers. But we also have teams that came from the application in the container-based world, meaning that we think in terms of reliability and performance of storage, but we also think about usability and workflow patterns. And we do that in a way that is by default built for a multi-cloud and hybrid cloud world. Portworx is the most widely used data platform for Kubernetes, and you can see a very small selection of our customers. Really what this slide intends to show is that chances are, no matter what your use case, no matter what your requirements, we've had a customer that we've worked with to solve those problems. And so we encourage you, if you like what you hear today, to reach out to us. We would love to work with you and help you deploy more applications onto the Kubernetes platform as well. So how do we do what we do, right? We're getting now to the crux of our content today. And I'm going to take about 2 more minutes because I want to talk a little bit about the Portworx platform. And you'll see that there are 2 boxes on here that are the topics of our conversation today: PX security and PXDR. So when Portworx looks at how do we enable enterprises to run these mission critical data services on Kubernetes when they have these very difficult business requirements that are not well suited in a pure Kubernetes environment or with Kubernetes alone. What we did is we said, let's break those requirements down into a couple of different buckets, and let's be the absolute best solution for each of those. And together, those solutions make up the Portworx platform. The Portworx platform's base is what we call PX Store. This is our cloud native storage engine. It provides container granular storage that's scalable, tunable, HA, all at the container level. If you've been following Portworx for a while, PX Store has been kind of the core of our offering for really since the beginning. And now we are kind of calling it something that will hopefully make it clear with respect to the rest of the platform. We call that PX Store. PX Central is really your user interface into the Portworx platform. Not only can you log into PX Central and you can kind of manage your volumes, understand your cluster, even when it's run on multiple clouds, but it has built-in monitoring and metrics, so you can always understand what's going on with your applications at a very, very fine-grained level. PX Data Management is another set of capabilities that we introduced with our 2.0 launch. And it really seeks to provide higher level management functionality on top of our core storage engine. So what do I mean by that? Well, for instance, Kubernetes is rapidly evolving as a platform, and what that means is that there are a lot of upgrades going from Kubernetes version X to version Y. How do you make that when you have stateful applications like databases running on Kubernetes, that you can upgrade your cluster safely, that you can test it, that you can move that application between environments as part of scheduled or unscheduled maintenance? PX Data Management addresses this problem head on by providing application and data migrations with a single kubectl command. So I can take an application and its data, and when I say application, I mean the containers, the controllers, the YAML files that define that application, along with the data, and I can move it from environment 1 to environment 2 in an application consistent manner. I can back up to any cloud, and I can even do things like copy data management for testing, debugging. The next two, I'm going to turn it over to Prashant to talk about PX Security and PXDR. But before we get into that, I wanted to do a quick poll through GoToWebinar to just get a sense of kind of where folks are at with regard to their own Kubernetes deployment. So I'm just going to, first of all, I'm going to switch my screen to Prashant so he can present. And then I'm going to create those polls. So just give me 1 second. Okay, Prashant, so you are now presenter, and I am going to, I'm going to launch the first poll, which is a question for the audience. Are you running containers in production today? So if you could just take about 10 seconds to answer whether or not you are running containers in production. We're always curious about the state of adoption. Or folks, are fully committed? Are you kind of dipping your toe in the water? This would be really helpful for us to know, because I think a lot of these security and data management questions really come up when you are in that production environment. Okay, thanks everyone. So I'm just going to close that poll, and I am going to open another one, just to say, do you have any active projects that require running stateful services and containers? And what I mean by that is, are these problems that you're actively trying to solve, or are you kind of curious but not yet sure whether or not you want to deploy stateful containers in your Kubernetes environment? Just give folks another couple of seconds to answer that question. Okay, thank you. And the last question is, if you have funding established for your container projects, this is one of the things that we're kind of curious about with regard to enterprises. Is are containers bubbling up to the CIO level, to the VP level, where kind of there are management is taking notice and empowering architects and developers to actually go and do these projects the right way. So if folks just take another minute to answer that question, I'm going to turn it over to Prashant.
Okay.
Okay, thank you very much, Prashant. Take it away, please.
Thanks, Michael, and thank you everyone for joining us here today. We are extremely pleased to have you on board. The two things, as Michael leaded to the segue, and two things that are coming up with the new 2.1 release, and that's the details I'm going to dive into, are around PX Security and PXDR. Let's start with PX Security first.
Hey, Prashant, sorry to interrupt. I can't see your screen. It looks like we're still in the poll, so give me 1 second just to. Can you try to reshare your screen, please?
Yeah, I think I can.
Yep, we've got it. Yep, go ahead, please. Thank you.
Perfect. All right. So on PX, let me start with PX Security first. So what's happened in the last year or so, as customers have ramped up their environments in production, data security has been front and center of our conversations with our customers. We've always had data encryption at rest, which was provided by integrating with industry key management solutions. And that covered the customers in terms of data, just securing the data in general at rest. but they did not secure or it did not control the access to the data. And that's where all of the things that I'm describing here under PX security come into play. Authentication, authorization, encryption, and ownership. And I'll describe ownership because it's more of a term from Portworx, but that is very blended into what PX security is. But the key question was, as we are talking to the customers, is that most of our enterprise customers have established security policies when it comes to controlling how their users set up user authentication credentials and who has access to what. And these are often determined by the group the users belong to or the role the users are in. And all of this is done by integrating it with existing user management systems like LDAP and Active Directory. And as the enterprises have kept on adding applications, products, services to their portfolio and expanding their user bases, they have basically applied the same set of controls to prevent compromises and breaches when it comes to security. Cloud native applications are no exceptions to this. And even though a lot of these controls exist in Kubernetes, there is no way to authenticate and authorize access to data. And that's where PX security comes in. So what do we mean by when it comes to access and controlling access to data? Now, as Michael described, a lot of advantages of moving cloud native are around enabling that agility, enabling that data agility. And the key things to enabling data agility is as users or administrators onboard their applications and bring more use cases to the platform, they want to sort of take a back seat and let the users basically collaborate, share, and move very fast at the pace that their businesses require for innovation. But this comes without the right amount of trust and controls. This comes with some inherent risks, and that's where PX security comes in. What we've done is we've added these features natively in the data layer for containers. And by doing that, we not only empower greater agility in application development, we create a circle of trust around the administrators and the users. As shown here, you can add more users, you can bring users on board, but as long as if the users don't have the right authentication credentials, they are basically not allowed to join the data platform. And then if once they're in the platform, they can develop, collaborate, do the things that they're used to doing, but they have to pass through the right gates first. We've not only done this we've done this at the layer by integrating it with our open storage SDK, which is adhering to industry web standards. So we've used existing industry standards around authentication, authorizations, encryption as far as possible to make it very easy for our customers to securely onboard any application to the Portworx platform and bring the cloud native architecture to their enterprise. So let me go in detail around all of these pillars of security. So let me just describe authentication at first. What's our approach to authentication? We are using a token-based authentication model. So no longer we are using any username, password, where you have to store passwords, keep as the users change passwords, you have to apply the right controls to it. All we do is we connect with existing OpenID Connect systems to provide the tokens, or you can generate your self-signed tokens manually. By using a token-based authentication, it's very easy for administrators to make sure the security model is consistent and works across the board around all their applications. Let's look at authorization. When authorization means once I have access, once I've identified who I am, what access do I have? And that basically means what access do I have in terms of the SDK layer and in terms of using the right APIs when it comes to using the platform. With our authorization model, we have RBAC integrated directly into SDK, as I mentioned, and we bring default roles, and then we also enable you to create your own custom roles. So that way you get a granular layer of access control, and it's single across the board, across your Portworx and Kubernetes investment, and it's not separately done, which basically beats the purpose, because then it makes it very hard to use because you have multiple layers of access control. Third thing is encryption. As I mentioned, we have always had encryption of data. Here we are also encrypting your access to SDK. And this is doing both, not one or the other. And this is using the same key management solutions that we've had. Lastly, as we're building the security model, it all comes through who is the owner of the data, right? So if you define the ownership model correctly, and if you give your users the right set of permissions, be it through groups or be it for collaboration, you can you don't have to have a trade-off between security and sharing, and you can do both together. So let me run you through some examples of how we achieve that. Let's look at authentication first, because that's how the users get onboarded to the system. Here's an example of an authentication where you have a user who's come in, he's come in and joined a secure platform, and he wants to create his own volume. So what does the user do? He gets a token from the admin, and that is his token to do everything related to basically to use the APIs for the platform. Once the user requests this token from the OIDC, once he gets the token, he sends the token with the request to create the volume. As a part of the token, he describes who he is, what group he belongs to, and what is his role. He can also describe other things like collaborators and so on, but those can be also added later. Once the user has provided the token, what Portworx does in the background is validates the token public key with the OpenID and make sure the user is who he is, and then he grants access to the user. So once the user is able to create the volume, then he can go on and he's the owner of the volume. And as you can see in the example here, the user has established himself as the owner, he's established the groups that he belongs to, and also has started collaboration with the user 2. When the user 2 comes on board and he wants to create a snapshot, what he does is he also processes his own token to identify himself with the system. After Portworx has validated the public key and understands the role of the user in the system and whether he has the access right API, the user is granted the privilege to create a snapshot. Let's take a case where a user 3 also has a role, he also has a valid token, but doesn't belong to the right group. So when the user 3 comes in to create a snapshot, he or she is not able to do that because the token, the groups that are mentioned in the token from the volume 1 are not there when it comes to validating the user 3 token. So this is how you can prevent rogue users from doing wrong things on the system and make sure that your system is authenticated with the industry standards. Let's look at authorization for a minute. What authorization is, which SDK calls do I access for? So we begin with three default roles. One is a system admin, which basically has access to any SDK call. A user who has access to administering and doing all volume level operations, be it creating volumes, creating snapshots, so on. There's a third user also, which is a third role also, which is system view, which allows the SDK to make only read-only calls. So, for example, if you've created your volume and you've done your, you won't just give a view-only access to the dataset. You would give that particular user the system view role and make sure that he has nothing but that access. But at the same time, we can enable you to create custom roles, and these are done by defining the right services and right APIs. An example here you can see we've said, we've done regex on enumerate API on a service volume. So all the APIs allowed there are only the enumerate APIs, and that's the custom role that you can create and provide to your users. Again, this RBAC is all integrated at the API level and SDK, and I'll tell you what the advantages of this when we talk about the orchestrators here. Encryption at Portworx has been using the BYO key, bring your own key mechanism. We've integrated ourselves with several key management stores, be it Vault, Google, and all cloud providers, KMS solutions, as well as IBM Key Protect and others. Now, when it comes to encryption at rest, we've done that, as I said, in the prior releases. This release adds using a different key or a different token. You can do basically access to encrypt the access to the SDK as well. Lastly, let me explain how ownership works. What ownership enables is gives you granular access control. When I, as a user, create a volume with my token, I am the owner of that volume. As in this case, the user 1 is the owner of the volume. The user 1 is part of group 1 and group 2. So group 1s and the Unix level permissions that the groups bring with themselves apply to that volume as well. But say I want to give a temporary access to user 2 and want the user 2 to collaborate with me. In this case, the user 2 might not be part of group 1 or group 2, but if I give him the collaboration access, he or she can collaborate with me on that particular volume. I can also give that access to another user at a view level. So what I'm saying is the ACLs for group and collaboration permissions are at admin, read, or write level, and they can be very, very easily controlled and given very granular access for a specified amount of time. So how does this work with existing systems? That was the key point which I started with. You have your LDAP and Active Directory systems. They are already integrated with OIDC like Google, GitHub, Keycloak. All we need to do is set up the Portworx as an account in these OIDC systems and create the import all your users into the system and give them the right access and right controls and use them to use these systems to generate the key. You can also use manually generate self-signed tokens if needed. One thing, an example here is for users who have not used any of the existing OIDC systems, they can also use Keycloak, which becomes an open source, and it's very easy to use for such for creating the tokens and the privileges. Right, now let's talk about how this works with Kubernetes. Kubernetes has its own RBAC. Now let me make sure that you understand that this our access control authentication is at the SDK level, at our data access level. So it's different, and at the same time, we are well integrated with Kubernetes. So how does it work? If the users, if you're making using Portworx Kubernetes entry driver, we use our 9001 REST server, and that's where we integrate with you as far as security is concerned. If you're coming via CSI, then CSI is very tightly integrated into SDK because the CSI sidecar containers provide all the secret information that we require to correctly apply the security controls via the SDK. Now, by doing it at the SDK level, you can see that we already have a benefit because we are supporting clients coming through two different mechanisms. One thing to note here is that when it comes to using the entry driver communication, the authentication that we rely on comes from Kubernetes. That's because CSI directly provides us the access to the secret and the token, whereas when it comes via the entry driver plugin, we rely on Kubernetes to authenticate the users and then use the tokens from our side. So as far as the path to CSI is concerned, the CSI is 1.0 as of 1.13 release of Kubernetes, and security will be available from that release as of CSI and will be supported from 1.13 release of Kubernetes as far as the CSI is concerned. What about when it comes to other orchestrators? So for, as you know, Portworx supports any scheduler. So apart from Kubernetes, we also support DCOS, Nomad, and so on. And both of these orchestrators access the Portworx layer through Docker Volume API. So using the Docker Volume API, users pass inline volume specifications to and then do the request to create the volumes, create snapshot, and so on. As a part of that inline spec, they will pass in the token, and that's how we will get the token, and we'll make sure that the authentication and authorization are rightly followed as far as the policies are concerned. So it's a very straightforward use for using through the Docker Volume API for users of DCOS and Nomad. So this is where this is all about PX security. PX security is available in 2.1, and we'll now talk about PXDR here for a minute. So again, as we have had users on ramping up on their production environments, with 2.0, what we brought to the table is application and data migration. The key thing to remember here is not just data, it's not just app, it's app and data together. And both of these together facilitate a lot of use cases when it comes to migration. You can do capacity augmentation. You can bring up a new cluster when an existing cluster has reached its capacity. You can do blue-green deployments. You can do lift and shift for legacy applications. You can do maintenance when it comes to migrating an entire cluster to a new hardware. So all of this has its own advantages when you do app and data together. What we wanted to do is take this story even further and do this with for DR. And the key component here, which enabled us to do app and data migration, is Stork, which is the scheduler orchestrator for Kubernetes that Portworx has open sourced. And that is what enables us to do hyperconvergence, migration, and disaster recovery. So let's look at DR for a minute. What do we do when we have to do data protection, recovery, and enable business continuity? So one thing to realize here is existing solutions that are in the market had limitations when it comes to doing this for cloud native applications. They were all either hardware based. It needed some rejiggering of the networking to make sure this works in a complex environment like Kubernetes. So in general, these existing solutions did not understand how to enable DR for cloud native applications. What we do by the legacy approaches also did not understand Kubernetes, because in Kubernetes applications get packaged in pods, they're managed by controllers, they're authorized by namespaces, and access data through persistent volume chains. Just by replicating at a SAN level between data centers without Kubernetes applications was totally insufficient when it came to doing DR in the cloud native world. So what does PXDR do differently? PXDR enables complete Kubernetes failover protection, and it supports app protection, which is namespace aware. What this means is enterprise architects can select which applications to protect and what level of protection to provide based on Kubernetes namespaces. Also, most important is this is also fine-grained control. You can do it at the app level or the selection of apps that you want to do. One other key component here is we use a mediator. That mediator is integrated with enterprise data centers, which helps us to identify failovers or identify events, and then failover using on-prem hooks and using a service in cloud that Portworx provides, which helps us to make sure that when a particular event happens, we seamlessly failover to a standby cluster on the other side. Now, in order to support any data center topology, PXDR comes in two forms. It replicates data synchronously or asynchronously across both campus networks and using WAN networks across different centers, which are very geographically separated. So let's take the first use case here. How do we do instant failover protection when it comes to data centers in a campus? So you have two data centers which are located fairly close to each other, which forms the campus environment. Portworx cluster stretches across these data centers and provides synchronous data protection and central management. The way it works is you have a pair of Kubernetes clusters, which is an active cluster, which is continuously and periodically sending backups and configuration to a standby cluster on the other side. Portworx always did volume placement based on fault domain. We detect fault domains by integrating ourselves very closely with Kubernetes, and we make sure that we place volume replicas in each different fault domain. So once all of this is ready, the standby cluster is pretty much running all the controllers, configuration, and PVCs, and it's mapping to the same volumes and replicas. When the data center one goes down, Portworx detects that data center one is not available through, again, as I said, through an infrastructure or a cloud service. And then it starts to automatically promote the applications which on the standby cluster, which were ready, and they start to spin up the pods. Volumes were already syncing the replication data. And since standby PVCs were ready, the RTO is near zero. RTO is near zero, and RPO is actually zero. Once DC1 comes back online, Portworx can again resync data back up to the new, backup KTS to the new data center, and you can promote either of those clusters to active-active. Now, again, I'll point out here the key differentiation we should emphasize is the networking here is all at an IP level, at the layer 3 level, and whereas the SAN-based networking is at the layer 2 level. We are not only moving data, we are both moving applications and data along with the config for Kubernetes. Existing solutions did this with the application, only with data, and left applications in isolation. By integrating with the fault domain detection with Kubernetes clusters, we know exactly when the fault domain occurs, which allows us to get the standby clusters to spin up the pods in a time which allows us to RPO and RTO SLAs. Let's look at the async case for a minute here. In the asynchronous case, you have two data centers geographically separated, and when I'm saying that, it's basically across, say, across the transatlantic. And you have an active site which is running, and you have a standby site which is basically where the active site is continuously sending incremental changes for applications and Portworx data. So the standby site is ready, it receives the data, it maps it to the objects and the infrastructure, and keeps the KTS controllers running and ready. It does this periodically. You can do it with a configurable period of, say, 15 minutes, or you can do it over an hour. It all depends on how you want to configure that scenario. Again, in this case, when the data center one goes down, the failures outage is detected based on the integration the same way we did for the synchronous case. And the standby clusters are promoted automatically to serving and serving up and already running the pods, which are all which can be spun up, and the applications can be served with data already available there. So just to make sure that the case is well understood, the campus networking is where data centers are close by, latencies are low, whereas the asynchronous case is where data centers are geographically apart, but still over the WAN, we are enabling the replication and enabling both application and recovery for data in a 15-minute sort of RPO time. So those are the examples. We have a lot of details also featured in our blog with 2.1. 2.1 release will be available in the next couple of weeks, and we should have all of the documentation ready for you to go through that. We already have a couple of demos for PX Security and PXDR, and both of those demos are available on our blog. I'm going to go give you a quick peek at the PXDR demo here, which will show you how this works with both synchronous replication. Give me a second here. So I'm going to quickly forward here. So what it did here was it basically has set up a cluster pair, and now because it set up the cluster pair, as soon as the WordPress and MySQL containers come up, the pods come up, and the volumes are all provisioned, Portworx in the background will start making sure that the data, they are basically synchronously replicated as far as data is concerned, and the apps are available on the standby clusters as well, ready to go whenever the first cluster goes down.
Hi, everyone. This is Michael. Just a reminder while we're watching the demo, if you have questions, please put them into the question box. I see that we've already got a few. So as soon as the demo is over, we will go ahead and answer all those questions. Thanks a lot.
Cool. So we have one cluster ready to go here, and yeah, I'm just going to skip this part because this basically is setting up some data through a WordPress site. Yeah, the policy is what defines how the DR works. In this case, it's 1 minute interval. That's the schedule policy. all the things are set up on the source cluster. Pair is set up. Now let's see how the DR happens. Let's skip forward and see what happens when the source cluster one goes down. Yeah. So on the destination cluster, because of the migration, the volumes are also ready to go. Correct. Yeah. So the destination cluster is ready to glow. So this is basically showing if trying to simulate that the source cluster is going down. And the application is also migrated. Yeah. So that you can saw, as you can see in the demo, PXDR is fully integrated with Kubernetes. This way, Kubernetes administrators and IT now have a true cloud-native approach when it comes to recovering their apps and data. So this is all we had in the webinar. We're going to look at the questions now, Michael. So we're ready to answer them.
Yeah, thank you very much, Prashant. I'm just going to go down the list. John asked a question about, I think in one of the earlier slides, he had seen AWS and Azure logos, and what was the question was, what about GCP? I can answer that one. We totally support Google Cloud, so that's no problem whatsoever. In fact, you can go on our website or just Google, MongoDB GKE or Kafka GKE, and you can find all the content that we have about that. A question for you, Prashant, from Mike is SAML supported?
So SAML is not supported because SAML was one of the older standards when it comes to creating token-based authentication. So we are using OIDC as our get-go. Depending upon how we see the customer interest, we may go forward and support SAML as well.
Okay, thank you. Next question for you, Prashant, is there a bandwidth requirement for the replication between data centers for PXDR?
So the bandwidth requirement in the asynchronous case is all dependent on the WAN network available. As far as latency is concerned, on synchronous, we are looking at 15 seconds. And on the asynchronous, it will be configurable based on how you want to, what's your periodic upload on the standby side. So it can be schedule based, and every 15 minutes, we'll be able to make sure the data is available on the other side.
Okay, great. So I have a question from Tom, more about organizational alignment, and I think technology. Prashant, maybe you can take a stab at this one. So the question is about stakeholders who are responsible for secure DevOps. So he's saying once policy set and enforcement is deployed via Portworx, as you demonstrated, where are alerts sent, who responds to them, and who's responsible for mitigation? Can you talk a little bit about how you see kind of data security playing out in practice?
Yes. So, when you enable the security, when you enable all the controls that you have, and you're getting users onboarded, we do have every action on a secure cluster is written to an access log and as well as to an audit log, and we are going to be generating alerts based on that audit log and sending it back via Portworx interface, either through the API or through Lighthouse. So you will be able to see alerts as far as security access, any exceptions that are happening in the system. You should be able to see that.
Okay, great. One other question from John is there. The question is there an additional cost for PXDR add-on? The answer to that is yes, but we're in kind of an early access period. So if you would like to try it and see if it works for your use case, I encourage you to reach out either to your support team if you're already a Portworx customer, or to your account executive if you're a little bit earlier in the customer journey. Okay, so we got some more questions that came in. So one question is about kind of the asynchronous use and it being snapshot based. So I can answer that. The asynchronous use case is snapshot based. What we found with our customers is that they deploy the HA within a single data center, DR across data centers in a metro area, and the asynchronous replication across the WAN together. So basically, it's three components of a broader DR strategy, which kind of allow them to get levels of availability or levels of data protection for their application that kind of have a cost performance optimized design. So thank you for that question. And if you have any additional questions about the asynchronous use case, please reach out to us. We're happy to kind of get into all the nitty-gritty details with you. A question for you, Prashant. Is VMware vCloud Director supported or only vSphere?
Right now, it's vSphere. We're looking at vCloud. A couple of our customers have brought it up, so that's something which we are looking in future to support.
Okay, great. And another question about PXDR, how do you configure asynchronous versus synchronous replication?
Both of the asynchronous and synchronous replication can be set up, as you saw in the demo, by defining your source and destination clusters and pairing up the clusters through either using the API or using the command line. We're also going to be making this available through our PX Central, which Michael alluded to, which is our UI, and that should allow users to configure PXDR from there.
Okay, great. Thank you, Prashant. That was our last question. So I wanted to thank everybody for attending our webinar today. If you have any other questions, don't hesitate to reach out to us. If you go to portworx.com, you can click on the big orange button at the top of the website that says Request a Demo. That form will come directly to our technical team. So kind of all of your technical questions we can hop on the phone and answer. We can also line you up with an early access to PXDR to test it out in your environment. If you want to kind of get a little bit more hands-on with Portworx, we encourage you to download Portworx Enterprise. You can try it for free for 30 days. We also have interactive tutorials and demos on the Katacoda platform. If you just go to our docs, you can access it there via interactive tutorials. So lots of ways for you to learn more about the solution and how you can successfully run data services on Kubernetes. So that I am going to end the webinar. Thank you all so much for joining us, and we hope to see you again soon. Thank you. Bye.
Thank you.